The first company I want to talk about is Sitka Gold Corporation. This is one of our newer investments. Times have been tight. We haven't had a lot of money to put towards new stores, but this is one that we cherry picked late last year, and it was based on some results that came out from work that Sitka did at their RC project in, I think, September of 2023. Okay, a little refresh here. Sitka is exploring a reduced intrusive type gold system. They are up in the Tombstone Belt in the Yukon, and they are exploring a system that is very, very similar to Snowline Gold's Valley the deposit discovery. All right, this is an intrusive related gold system. So basically, you have a granite body. In this case, we see some kind of squibby lines going across there in pink. That is an expression of an underlying granite body. Those are big fat dikes that have come up through the ground and crystallized, but they are closely associated with gold. Okay, and the drilling done to date has defined a very broad, sizable gold resource. But what's really intriguing is late last year they started to hit some very high grade mineralization. With respect to this type of deposit, they hit 124 meters of 2 grams in one hole. And within that, there was 55 meters of 3 grams, very much like what we see at Snowline, in fact. All right, so the holes that you see in the green, those 2 green dots, those are holes, the first 2 holes that were drilled this year, 57 and 58. 57 was drilled first. You can see it was drilled at a fairly steep angle to the northeast. And in 58, the position of 58 is about 70 meters north of 57 and slightly to the east. And again, it was drilled at an angle such that it was a fairly steep angle to test the same, general vicinity of where that high grade was. So let's go to the next slide and let's look at a cross section. All right, so here you see hole 58. Looks actually not too different than the cross section for hole 57, but you can see it's gone through the upper dike. It's gone down, hit a bit of sediment in the greens, and then it goes into the dike again. In fact, they hit a very, very long width of that dike, given the angle they were drilling. And you can see that's where the high grade was in hole 47 from last year. That's where that 124 meters of 2 grams was, including the 55 meters of 3 grams. Okay, so we're going to give this thing a very, very good test. Once again, it's deeper in the system. I'll be very interested to see what kind of grades come back, particularly because they did see visible gold in some of the veining in this hole. Let's go to the next slide. And here you can see some of the core from that zone. This is within the dike structure itself. So you can see in the core kind of a speckled, a white and black speckled rock. That is that granite intrusion. One of the theories that I have is that the coarse white blobs that you see in that intrusive rock are an indication that we're at the top of a granite mass. Okay, those things are called phenocrysts. They're basically crystals that were forming when the magma was molten, and they tend to float up towards the top. So when you see what we call a crowded porphyry, where all of those little crystals are collecting, I get pretty excited. That tells me we're probably at the top of a magma chamber, and that means that we have a lot of runway, a lot of room below us, where there could be a very sizable system. In fact, maybe all we've seen to date is the smoke above something much, much bigger. Well, further support comes from the fact that they see visible gold in some of the veining. Okay, the kind of linear features, often light gray, maybe somewhat tannish gray in this photograph, that you see are quartz veins that crisscross this core. And the quartz veins, we call them sheeted veins because they're very flat, linear features that cross the core at fairly regular intervals. A lot of those quartz veins have wee bits of gold. You can see in the photograph down here in the lower right-hand side a bit of gold. That's a very small particle, but that's very typical of this style of gold. We've seen this same style at Snowline. We've seen it at other deposits, Bangin, Fort Knox. All of these deposits have gold of this type. And very commonly, we see the gold intergrown with a sulfide phase. In this case, that little grayish blob that's kind of to the right of the gold particles. That's probably maybe bismuthenites, or maybe it's even arsenopyrite. I don't know, but it's a little bleb of sulfide that occurs with the gold that's very common in these systems. So in my book, that is a typical occurrence of gold in a reduced intrusive type system. This has got, it ticks all the boxes for me, and this has got all the hallmarks of a big reduced intrusive type system. And I think as they explore this thing, especially at depth, I think they're going to see more and more mineralization. All right, let's go to the next slide. And by the way, assays are going to take a few weeks, but hopefully we see them sooner than later. I think, given the slow nature of drilling at this point in the commodity cycle, I think these guys should be able to get this core through the lab fairly quickly. So hopefully we see some assays soon. Anyway, this image shows you the broader RC project area. You can see the saddle stock and the Niagara deposit. Between the Blackrock or Blackjack deposit and the Eiger deposit, there's nearly 1.34 million ounces of gold in inventory right now. That's early stage, lower grade resource, but it's this deeper mineralization. The fact that we're seeing a bigger footprint of this, a very large reduced intrusive system here, that I think is the most intriguing. I mean, this is certainly shaping up to something that can be much larger, and now we know higher grade. Okay, let's go to the next slide. All right, one of the companies we're very excited about, Hercules, put out some news this week talking about some geophysical works they did, geophysical work that they did in I think it was done over the winter here, the winter months, basically to look at the sulfide system, this buried porphyry system, and how it responds to electrical surveys. Okay, so when you do an electrical survey, in this case, it's basically what we call induced polarization IP chargeability survey. We're looking at the electrical behavior of the rock in the ground. Okay, often with mineral deposits, there is sulfide present. And the sulfide that is very common in almost any ore deposit is pyrite, okay, or iron sulfides. And pyrite, if it's evenly disseminated through a rock, it can be quite chargeable. In other words, the little bits of pyrite, as electricity is pumped into the ground, they tend to collect electricity, so they become charged. Think charged like a static balloon almost, but for a brief period. Okay, and then the other thing is, if the sulfides are touching one another, in other words, if they're all kind of crowded together and they touch one another, you can develop conductive features. In other words, the electricity can pass from one grain to another and actually pass through the ground. So we're looking at the behavior of both the chargeability and the conductivity within the ground. Okay, now this survey in particular, found that there is a conductive area, which is really intriguing. And their interpretation is that this conductive area is an indication there's a sulfide, like intense sulfide, that might be, interconnected with one another, and therefore, is conducting electricity. And therefore, they kind of use that, or they interpret that as a proxy for a more intense sulfide endowment in that area. Okay, what does that mean? It could mean there's higher grade. Okay, we'll see, but we'll talk about that more here in a second. Okay, we're also seeing a pretty consistent chargeability throughout a very large volume of rock as well, and that's telling us there's a big sulfide system here. Okay, let's dive in and talk about some of the details here. Let's go to the next slide. Okay, so in this image, we are looking at chargeability. Okay, again, this is where the minerals, particularly pyrite, are becoming charged. They soak up the electricity, they kind of hold it for a moment while the survey is being done. So you can see it's almost like an X-ray in a sense of where the sulfides, disseminated sulfides in this case, are located. Okay, so the bright pinks, obviously, that's where there's strong pyrite. And you can see most of the drill holes that were completed last year in 2023. Those are those linear things with the little ticks of blue flagging by them, and then orange flagging. So the copper and moly values are expressed. And you can see most of those drill holes fall within that strong pyrite area. Okay, but that's not necessarily where the copper is. Chalcopyrite doesn't necessarily charge up like pyrite. Okay, so what they're suggesting here is that much of that drilling they did last year was in, we'll call it the most intense pyrite area, but not necessarily the most intense chalcopyrite area. They're actually saying that might be outboard from that. Okay, so where it says target corridor, they are interpreting that area where the chargeability is somewhat less. Okay, that you're seeing reds and oranges rather than pinks. Their interpretation is that is where there might be stronger chalcopyrite. Okay, so that's giving some reason for them to test out into that region. Okay, now let's kind of pick this apart a bit more. Now, first of all, the elevation of the chargeability, that's 800 meters. Okay, that's with respect to sea level, I believe it is in this case. So think of this as like a horizontal slice of the ground at a fixed level. Okay, go to the next slide now. Now we'll look at a cross section. Okay, unfortunately, the vertical scale isn't on here. But think of the slice that we just saw, more or less being right about in the middle of this image. Okay, this is in cross section view, so we're looking at from the side. But that horizontal slice is roughly where the middle of this image is. Okay, and what they're saying, this is looking east, by the way. All right, so what they're saying is this area, mainly to the, we'll say to the left of these drill holes, the little linear features you see there, they're drill holes. They think that is where more of the chalcopyrite resides. Okay, so it's kind of in the area where there isn't necessarily as bright a pink, but they interpret that to be a sweet spot. So that's consistent with the vectors and grades that they saw from the drilling, that they are heating up towards the north and northwest. It'll be interesting to see what they come up with. They're planning to put some holes in there, and we might see much higher grades in that area. Okay, let's go to the next slide. Okay, now we're looking at an image of conductivity. This is not chargeability. This is how well the rock or the minerals in the rocks in the ground conduct electricity. Okay, how easily the electricity passes through the rock. And this is at 900 meters elevation, so it's slightly higher than the previous one. But you notice that there's a shift. There's a fundamental shift here. In the previous image, we saw most of the bright pink was towards the middle of the image. In this case, it's shifted. So now the most conductive area is towards the south. Okay, and this is the view here is that the reason this is more conductive is that there's a higher endowment of sulfides that makes it the electricity easier to pass through the rock in this area. Does that necessarily translate to mineral endowment? We don't know. There's also a magnetic anomaly down here. By the way, magnetite can be somewhat conductive in the right conditions, so maybe that's explaining it. But it does suggest there is perhaps more conductive minerals, perhaps sulfides in this area. Okay, go to the next slide. And now we can see from this image in a 3D rendition here, these blobs that you see, these bluish blobs are areas that are conductive, that are shown in 3D. So they're projected down into the ground. And we can see that they extend well below some of these mineral occurrences at surface. Okay, all of these little names that you see here are various shafts and adits and old mine workings and whatnot. And we can see they're very closely associated with the projection of these conductive features down into the ground. What might it mean? Well, my gut says when I see conductive features like this, I think of skarns. Okay, that's just me. Often magnetite skarns with with a fair bit of sulfides, hopefully ore mineral sulfides like chalcopyrite and stuff. That might be what we're seeing here. Okay, that's just my gut. That's my gut. It's probably not exactly the same way the company sees it, but I do think that might be an explanation of what we see going here. And that would also explain why this is to the south of what they're interpreting to be more of the copper core of a porphyry system. To the north, this is more on the fringe. Again, it's going to have to be drilled to figure out what's really going on here, but I think they got a very good tool to work with here in both geophysical sets. So they do have a pretty robust plan coming up there for this year. A lot of money in the bank. This is one of the best cashed up juniors out in the market, and I think they're going to make further big discoveries this year. Go to the next slide, please. All right. This week, Newfound announced some results from actually towards the north end of their mineral system here along this Appleton Fault corridor. And notice, this box where figure 2 is, where I point with the green arrow, the results in this news release are way up there in kind of that area that almost looks like it's getting broken by a nutcracker. You've got the Appleton Fault corridor, but you have a second fault, and we're going to talk more about that. And in this area where you're seeing these veins, this intense veining with this very high grade mineralization, is right there in that area where they start to connect. Go to the next slide, please. Okay, here's a close-up of that. So you can see the Glenwood shear zone, which is the gray feature towards the northwest or the upper left, is getting closer and closer to the Appleton Fault corridor, which is the other gray feature that you see kind of going through the middle of the image here. Up towards the north there is where they start to really get close to one another. Okay, and it's in this area where they're seeing, look at all the red boxes. Those are results from this news release. So holes that were announced in this news release from this area where veining is trying to bridge or connect those two structures. And often where you see two structures like that, two principal structures that have a lot of movement on them, try to connect with each other. It's usually a zone where there's a lot of breakage in the ground in between. Okay, and that can be where you get a lot of mineralization. I think we're starting to see that here. Let's go to the next slide. This is a very complicated image. It's looking at that whole picture in a different angle. So we're looking orthogonal, or not orthogonally, we're looking obliquely to the southeast. So now we've got the Glenwood shear towards the bottom of this image. The Appleton Fault is above it. All right, but you can see all of these modeled structures, the reds and purples and whatnot, and orange you see here. This is where all this drilling took place, and there's a lot of gold through there, a lot of structures. What we usually call a situation like this, these are linking structures. They're basically brittle structures that try to connect the two shear zones, the two shear features, in this case, Appleton and Glenwood. Okay, and these can be places where you get a lot of gold. Okay, and one of the things I'd point out is much of this drilling is relatively shallow. Okay, they're seeing this mineralization at shallow depths, but given the data that we saw in the seismic recently, and knowing the nature of these epizonal gold systems, the mineralization could continue downward, and you can see a whole bunch more structures as they explore deeper and deeper. You can see a lot of drill holes here and there that have one-off hit, little pops of reds and oranges and whatnot all over the place. Guess what? There's going to be a lot more structures found in this area over time. I think this could be one of the more prospective zones of discovery here. All right, so good news out of Newfound. Let's go one more slide and talk about inflection. Okay, I haven't talked about inflection for a while. A little refresh. Inflection Resources is down in New South Wales in Australia, and they've got a super smart team of geologists. They're one of the best exploration teams in the junior exploration industry, and they've managed to pick up a very strategic land holding in this Macquarie Arc. This is basically a trend of rocks in the subsurface that have a very distinct geophysical signature. You can see that on the right-hand image, in this case, magnetics. And this belt of rocks used to be what we call an arc, an island arc, or a magmatic arc of some sort, basically where you had a lot of volcanism, a lot of intrusions coming up. And in this environment, you can get porphyry deposits, okay? You can get, in this case, copper, gold porphyries. And where these rocks outcrop towards the southern part of this image, you get world-class deposits. We have Cadia, we have North Parks, you got Cowell. I mean, there's some just monster porphyries in this country. But up towards the north, where these guys have staked their ground, that area is covered. There's a veneer of sedimentary rocks that blankets the area, and therefore we can see the geophysical expression of the belt, but we cannot see those rocks at surface. All right, so that means you got to use clever techniques, geophysics mainly, to evaluate the subsurface and come up with your targets and refine your drill programs as time goes on. So you can drill and make discovery. But we're going to talk about this Duck Creek area, and that green arrow points to approximately where Duck Creek is located in the tenement package. Okay, let's go to the next slide. Before I show you the details from their recent work, I'll talk briefly about the target style, what we're trying to find here. Okay, and in this image, you can see a cross-sectional view, a schematic cross-sectional view of a typical porphyry like you would see in the Macquarie Arc. And in this case, you can see they've got that post-mineral sedimentary cover. So there's a blanket, and this brown stuff at the top is basically a blanket of sediment that buries up all the rock underneath. It's not really that thick. I don't know why they show the scale bar down here at 1 kilometer, because the cover is actually only a few tens of meters thick. Okay, so a little bit out of scale, and I might point that out to them. But, that we're talking about maybe 80, 100 meters, a couple hundred meters at most, something like that thick. It's not a kilometer thick, okay? And also the top of the deposit is not 2 or 3 kilometers down. These are easier to access than that. They're probably, 3, 4, 500 meters to get to the top of the target. Okay, but otherwise the schematic's all right. All right, so the feature that you see there, the kind of the red, blob coming up, that is the porphyry mineralization, in this case copper gold. It's a potassic zone of alteration around a porphyry intrusion. A porphyry intrusion, simply a magma that came up and likely expelled the fluids and generated the copper and gold mineralization. All right, but it's got kind of a cylindrical shape to it. It's on the order of a kilometer, maybe a bit more wide, and it can be several kilometers tall. Again, it's not as deep as they show in this image, but we'll forgive them for that. Okay, but it's not easy to find this. Okay, you'd think, gee, that's a big target, a kilometer across. Surely you could hit that with a hole or two. No, on average, it takes probably 20, 25 holes to find the sweet spot in a system like this. And how do they do it? Well, because of the cover and stuff, they got to use some smarts here. And one of the tools they're using is geophysics. Let's go to the next slide. Okay, so in this case, in this news release that came out with this week, they did a survey over this Duck Creek area, and the area of the survey is shown in that shaded gray box on the left-hand side there. Basically, it's an area where the magnetics, which is the left image, shows a very distinct pattern of arcuate little blobs, we'll call it, anomalies. But more importantly, now they've got this survey that basically we'll call it a seismic survey, what we call a passive seismic survey. It's a fancy word, tomography survey, but it's really just a seismic survey to look at the speed at which waves can pass through, seismic waves can pass through the rock in the subsurface. And this is one of the first times I've seen this used in a very, a targeting mode. Okay, so they're actually using, passive seismic noise, like waves traveling through the ground, to look at the speed at which they pass through the rocks in the ground, in the subsurface below the sediment. And they're looking for areas where the waves pass through the rock a bit faster. Okay, because the theory is that those are areas where where the velocity is higher, where the intrusions would reside. Okay, so over here on the right hand side, you can see the areas that are reds and oranges and whatnot are areas where the seismic waves travel a bit faster. It's a bit hard to interpret, but I think the next image does a better job. So let's go to that. Here you can see basically a horizontal slice. And again, it's only 400 meters RL. Okay, so I don't know why we, anyway, it's not that deep, guys. It's pretty shallow, and it's a horizontal slice. And you can see where they've drilled the holes. Okay, they've got, let's see, 1, 2, 3, 4, 5, 6, 7 drill holes completed. It just so happens, and those were drilled before this data came back, obviously. Just so happens most of those drill holes test areas where the velocities are not as high as one would hope to see with a porphyry. But now that they have this data, they've got these very discrete, we call it circular features that are very suspicious of being, potentially an intrusive. Okay, and they've got those new targets. So each one of those yellow stars, each one of those gold stars, is a target they plan to test. And I think this is a really cool technique to hopefully hone in on the, a porphyry price in this area. Again, you can see the scale bar over here, kilometers. Each one of those things is on the order of a half kilometer, maybe up to a kilometer across, and gives us a reasonable target to test it. Why they don't have some of the other, high speed, high velocity areas chosen, I don't know. I don't know. I'm probably going to talk to the company here in the not too distant future. But right now, I can see what they're trying to accomplish, and they do seem to have some very discrete circular features that are perhaps intrusives that they can now drill test. All right, good science, good team. They're very smart. They're also in bed with Anglo Gold. Anglo is spending most of the money on this project, so the company doesn't have to dilute itself in what has otherwise been a very, very soft market. All right, so I think again, smart team, smart move to have Anglo Gold spend the money here in an earn-in structure. And I would urge you to look at their history of that deal with Anglo Gold to learn more about inflection. All right, so that's it from my end. Hopefully everybody has a good weekend. Gold is looking very strong, very interesting times coming. And I think we're going to see a long time ahead of us that we're going to have some fun in this exploration space. All right, thank you.